Hello everyone, this is our first problem. Graphically, find whether the following pair of equations has no solution, a unique solution, or infinitely many solutions. So first of all, we should know from the graph how we can understand whether it is having a solution, a unique solution, or infinitely many solutions. Okay, anyways, two equations are given. No, suppose the lines. Okay, if the lines intersect like this, we can say it has a unique solution. Two lines, if they intersect at a point, the coordinates corresponding to that meeting point is the solution of that system of equations. Okay, that is a unique solution situation. A unique solution means the lines will intersect at a point. Now, when there is no solution, the lines, what we get will be parallel lines. See, they won't meet anywhere. So there is no solution. And infinitely many solution means we have one line like this and the next line also coincide with it. See, if the graph we obtain after plotting the two lines, if it is like this, we can say there are infinitely many solutions. Okay, so these three are the situations. Now we have to plot these two lines. First, the given equation is this. Okay, first of all, we have to find out two or three pairs of values for x and y. That is the coordinates, possible coordinates for x and y, so that we can plot. So we'll write it as the value of x here, then value of y here, like this. Okay, so the easiest way is putting x as 0. Let us try. If x is 0, 5 into 0 in this equation. If x is 0, 5 into 0 minus 8 into y plus 1 equal to 0. 5 into 0 is 0. No, this is God. So minus 8y plus 1 equal to 0. Minus 8y equals minus 1. See, positive 1 going to the right side. So minus 1. See, then y is minus 1 by minus 8, or we can write it as 1 by 8. It is really difficult to plot 1 by 8 on graph paper, right? We need natural numbers, so we can have integers. So positive or negative, but integers. That will be easy to plot on graph paper. So this is not a good idea. If we give y equal to 0, then this term will be vanished, right? As before, if we give y equal to 0, this term will get vanished. So 5x plus 1 equal to 0. It will be like this. Again, 5x equals minus 1. Then we take this plus 1 to the right side. It will become minus 1, but x is equal to minus 1 by 5. See, this is also not good. We cannot plot this. So we have to find some other ways. Okay, here we have 5 and here we have 1. So if we give y equal to 3, what happens? Y equal to minus 3 is a good option. Y equal to minus 3. Okay, let us try that. What happens when y equal to minus 3? Okay, 5x minus 8 into minus 3 plus 1 equal to 0. Okay, 5x, then minus 8 into minus 3, that is plus 24. Then plus 1 is already there, this is equal to 0. So 5x plus 25 equal to 0. In the next step, we have to take this 25 to the right side, so it will be 5x equals minus 25, or we can write x is equal to minus 25 by 5, that is minus 5. See, we got integers, no, when y was minus 3. Okay, so y is minus 3 and the corresponding value for x is minus 5. The situation is like this. Okay, we can plot these values. Similarly, we have to find, see, here we got a multiple of 5. Like that, a multiple of 5 near to 1. Means when we add or subtract 1, we should get a multiple of 5 from 8 multiples. Like that we have to think. Next, let us try y equal to 2. Okay, let us try that. What happens if y equal to 2 in this equation? 5 into x minus 8 into 2 plus 1 equal to 0. Now, 5x, okay, minus 8 into 2 minus 16, then we have a plus 1 equal to 0. Minus 16 plus 1 is minus 15, right? Minus 16 plus 1, we are adding a negative number with a positive number. Negative is the bigger one. So we have to subtract smaller from bigger and put the sign of the bigger one. So it is minus 15 and here we have 5x. So 5x minus 15 equal to 0. When we take this minus 15 to the right side, what we get is 5x equal to positive 15, or we can write it as 5x is equal to 15 by 5. When we take this 5 to the right side, it will become division. 15 by 5, that is 3. Okay, so that is a possible value. Possible means we can float since these are integers. Y equal to 2 and x equal to 3. Next, let us try 7. When we put the value 7 here, what happens? 8 into 7 is equal to 56. We know here we have a 1. So if 56 is negative, okay, and plus 1 means we will get a multiple of 5. That is our logic. Okay, we'll try that. 5x, what we are trying is y is equal to 7. So 5x minus 8 into 7 plus 1 equal to 0. Then 5x minus 8 into 7 minus 56 plus 1 equal to 0. Minus 56 plus 1, that is minus 55. So 5x minus 55 equal to 0, or we can write 5x equal to 55. See, negative 55 going to the right side means it will become positive 55, or x is equal to, we have to take this 5 to the right side. So on left side, 5 is multiplied with x. When it is taken to the right side, it becomes division. So 55 by 5, that is 11. So we got the values x equals 11, then y 7. Thus we got 3 pairs. So we have to plot minus 5 comma minus 3 on graph paper, then 3 comma 2, then 11 comma 7 to get this line. Okay. Next we have to find out the coordinates for the next given equation. This is the second equation given. See, it is like 3x minus 24 by 5 y plus 3 by 5 equal to 0. Here we have two fractions, right? Both of them having the same denominator 5. Okay, so let us make here also a denominator 5. See, the first term is not having any denominator part. So if we have it, we can cancel throughout, right? Or for removing the denominator from here and here, we have to multiply by 5, right? When we multiply by 5, what happens? This 5 and 5 will get cancelled, right? So here also we have to do that multiplication. And here also we have to do that multiplication. See, when we have an equation, when we multiply a term with a number, we have to do the same multiplication throughout. Each and every term in that equation should get multiplied. See, if we do like this, what happens? 5 into 3, 15. It will become 15x minus. This 5 and 5 will get cancelled. So minus 24y. Then this 5 and 5 will get cancelled. So plus 3 is only left, equal to 0 into 5, that is 0. Okay. See here, or in other words, we can do it like this also. See, 3x, we need the denominator 5. Here actually we have a denominator 1. How this 1 will become 5? We have to multiply with 5. So the same operation we have to do in the numerator part as well. So 3x into 5, that is 15x. Okay, we can do it like that also. Then the equation will become 15x by 5. See, 3x is same as 15x by 5. Here, then 25 minus 24 by 5y. Then here we have plus 3 by 5 equal to 0. See, here for each and every term we have the same denominator 5. So we can cancel that, right? And because we have 0 on the right side, that is why we are cancelling it. See, when we cancel that 5, we are getting the same equation, right? We are getting the same equation. So whatever be the method we follow, we are getting the same point. Okay, now the equation is like this. Just let us check. See, each and every term is a multiple of 3, right? So let us divide throughout by 3. 15 by 3, that is 5. So 5x minus 24 by 3, 8. So 8y plus 3 divided by 3, 1 equal to 0. Here we were having 0. That is why the division was so easy. Okay, 0 by 3 is also 0. Now, we got the equation like this. We have to find out the value of x and y satisfying this equation as we have found out before. Now, see, this is the same equation what we were having here, no? 5x minus 8y plus 1 equal to 0. Here also 5x minus 8y plus 1 equal to 0. So, can we just copy down the values from here? See, yes, we can do that because the same equation, but now itself we know both the given lines, both the lines are alike, right? Both the lines are same means they are coincident. Coincident means they have infinitely many solutions. But the question is we have to show graphically. That is why. Okay. So let us take the same values from here and we will plot the graph. So here we have a graph paper with us. See, first we have to check to which range we have to move. On x-axis we have -5 and 11. See, -5 is here and 11 is here. Like that, we have to find out where we have to draw x and y axis. And y, we have -3 and 7. So how much we have to move in positive and negative directions, we have to decide first and then we have to draw the axis. Here I have drawn it already and we need these points x minus 5 and y minus 3. X minus 5 is here and y minus 3 is here. Okay, so -5 minus 3. This is the required point. Okay, so I am naming it as A and I will write what is A over here. A is actually -5 comma -3. Then we need 3 comma 2, x3 and y2. x3 is here and y2 is here. Okay, x3 and y2. So this is the point. I will name it as B and here I will write B is same as 3 comma 2. Now we need 11 comma 7. 11 is here. Okay, 11 comma 7. This is the 7. Y7. Okay, so 11, 7 is here. You will name it as C. C is actually 11 comma 7. See, we can write like this also if it is congested. If we cannot write down it properly here. Now we have to draw the line passing through these 3 points. Okay, this is the required graphical representation. And what we can say is, see, both the lines having the same points, right? Or we can say they are coincident lines. Coincident means infinitely many solutions. Hope all of you understood. This is our next question. Solve the following pair of linear equations graphically. See, we have 2 equations, x plus 2y equals 1, x minus 2y equals minus 7. Also find the coordinates of the point where x minus 2y minus 7 is equal to minus 7 meets the x-axis. Okay, so we have two equations. We have to solve them. These are the given equations. First, we have to find the coordinates corresponding to this line. So as we have done in the previous question, no, we have to find out the values of x and y. Okay, x and y, which will satisfy this equation. Okay, now here if x is equal to 0, what happens? When x is 0, this will become 0. So 0 plus 2y equals 1 or 2y equals 1, then y equals 1 by 2, which we cannot plot on the graph. So that is not good. So let us take x is equal to 1. Okay, what happens when x is equal to 1? We have to give 1 here, 1 plus 2y equals 1. See, 1 on both sides, right? We can cancel them. Because, or in other words, if we take this 1 to the right side, it will become 1 minus 1. So it will get cancelled. So what we got? 2y equal to 0, or we can say y equal to 0. Thus we got one integer pair, or we can say two integers which we can plot on the graph paper. So x is equal to 1 and y equal to 0 is the solution. Similarly, we have to find what happens when x is equal to minus 1. Okay, when x is equal to minus 1, what happens? This will become minus 1. So minus 1 plus 2y equals 1. Then 2y is equal to, see, when we take this minus 1 to the right side, what we will get? 1 plus 1. Minus 1 taken to the right side will become plus 1. So 1 plus 1, that is 2. So 2y equals 2 or y equals 2 by 2, that is 1. Thus we got another pair of integers satisfying this equation. X equals minus 1 and y equal to 2. Similarly, what happens when y is equal to 2? Okay, let us check. When y is equal to 2, y is equal to 2. See here, x is here, x plus 2y will become 2 into 2 equals 1. So x plus 4 equals 1. Next, we have to take this 4 to the right side. So x is equal to 1 minus 4. That is x is equal to minus 3. Enough. We got another pair of integers satisfying this equation. X is equal to negative 3 and y is equal to 2. Thus, we got 3 points corresponding to this equation. So we can plot. Now, similarly, we have to find the values corresponding to the second equation. This is our second given equation. See here, it is not good to put x equal to 0, right? When x equal to 0, this term will go on. So minus 2y is equal to minus 7, or y will become 7 by 2. Negative and negative on both sides. So it is ultimately positive value, but it is a fraction. It is difficult, no? Or we can, sometimes some kids may know how to plot this, which is the same as 3.5. But let us find out some integer values. Okay. Now let us give x equals 1. Then what happens? 1 minus 2y equals minus 7. So in place of x, we have given the value 1. Then minus 2y is equal to, we have to take this positive 1 to the right side. So positive 1 will become negative 1 here. Minus 7, minus 1. Minus 7, minus 1. Actually, it is adding two negatives, right? Okay, so it is minus 8. So minus 2y equals minus 8. That is y is equal to minus 8 by minus 2. That is 4. Okay, now we got integer values x equals 1 and y equals 4. Next, let us give x equals negative 1. What happens? Let us take x equals negative 1. So here this number will be minus 1. In place of x, we have to give minus 1. Then minus 2y. Minus 2y equals minus 7. Okay, so minus 2y is equal to, see here, negative 1 is going to the right side, it will become positive 1. So minus 7 plus 1, that is minus 6. Or minus 2y is now minus 6. What we can say, y equals minus 6 by minus 2, that is 3. Okay, enough. We got integer values. In place of x, we can give minus 1. And in place of y, we can give 3. Similarly, we have to find one more pair, right? One more pair is needed for x and y. Now, let us check what happens when y equals 1. Okay, let us give y equals 1. So x minus 2 into 1 equals minus 7. X minus 2 equals minus 7, or x equals, see, we have to take this minus 2 to the right side, so it will become plus 2. So minus 7 plus 2, that is minus 5. Okay, we got integer values, x equals minus 5 and y equals 1. Okay, enough. We got 3 pairs for x and y which are integers, so that we can plot them on the graph. So these are the values which we have to plot on the graph paper. Here we have a graph paper, and see, first we have to observe the range up to which we have to plot. Here x values, just observe, we have negative and positive values. Here also negative and positive values. On negative side, the maximum value is negative 5. Okay, that is what we have in our mind. And what about y? See here, all the y values what we got is only positive values, no? Okay, so what we understood is y-axis, no need to draw y-axis towards negative side. Okay, let us take this as the y-axis. Negative side is not needed, so let us stop by this. This is the y-axis, and x-axis we need negative side as well. Okay, let us do like this. This is our x-axis. Now, here we have x, x bar, y, and y bar. This is our origin. And okay, we need 1, 2, 3, and all. No, 1. If it is congested to write down the values here, no, we can skip 1. Okay, 1 in between. 1, 2 is skipped, and we will write 3. Then 4 is skipped, and we will write 5 like that. 6, then 7 like that. It goes here. Minus 1 is here. Here minus 2. Then minus 3, minus 4, minus 5, minus 6 like that. And here also 0, then 1, then 2 here, 3, 4, 5, 6, 7, 8 like that. Okay, now let us plot the values. First one is 1, 0, 1, 0. Okay, let me take another color. 1 on x-axis and 0 on y-axis, means this is the point, right? 1, comma 0, this is the point. So I'll name it as A, and I will write A is 1, comma 0. The next point is minus 1, 1. Here is minus 1 and 1. Here, right? This is 1 and this is minus 1. So this is the required point B. So B is minus 1, comma 1. Then minus 3, comma 2. Minus 3 is here, no, in between minus 2 and minus 4. So it is -3, then 2. So this is the required point. So we'll take it as C. C is -3, comma 2. So this is the required line, graphical representation of the first equation given. Okay, after drawing the line, we have to mention the equation. See, this is x plus 2y equals 1. Like that, we have to write down the equation near the line drawn. Next, we have to plot this line, right? We have to plot the next one. Let me take green color for that. Okay, see, first point 1, 4. On x it is 1 and on y it is 4. So this is the required point. Okay, let us take it as P. P is 1, 4. Then -1, 3. -1 is here, -1, and P is here. See, 3. So -1, 3. This is the point Q. So Q is -1, 3. Then next one, -5, 1. -5 is here and 1 is here, right? So -5, 1. This is R. So R is -5, 1. Now we have to connect these 3 points through a line. Okay, this is the required line for the second equation given. Okay, we have to show the points which we have taken. Okay, so and C was actually -3, 2, no? -3, 2. Okay, this is also point. Okay. Now, see, we have plotted the line. We have to mention the equation x minus 2y equals -7 over here. And see, this is the point of intersection, which is -3, 2. Okay, -3, 2 is the solution. The question was graphically we have to solve. This is the solution. Solution means the point at which the two lines intersect. Okay, -3, 2. Now, one more part was there, no, for the question. We also find the coordinates of the point where x minus 2y equals -7. See, this green colored line meets the x-axis. This is the point where it meets the x-axis, right? So, this is actually which point? This is -7, right? So it meets at x equals -7 is the meeting point on x-axis. This is our next question. Draw the graphs of the following pair of linear equations. See, we have two equations here. We have to plot them on graph paper. Determine the coordinates of the vertices of the triangle formed by the lines represented by these equations and the y-axis. Okay, so first we have to plot these two equations. Now I have written the first equation here. Now, see, we have to find the corresponding values of x and y. No, x and y values which will satisfy this given equation. So let us try. If x is equal to 0, what happens? X equal to 0, then this will become 0, no? 4 into 0 minus 3y minus 6 equal to 0. 4 into 0 is 0. So minus 3y minus 6 equal to 0. Or when we take this minus 6 to the right side, it will become minus 3y equal to 6. That is, y is equal to 6 by minus 3. That is -2. Okay, we got a pair of integers which we can represent on graph. So x equal to 0 and y equal to -2. So another pair we need, no? Let us try another pair of values, or say what happens if we give y equal to y equal to 2. Okay, let us try that. What happens when y is equal to 2? So here we have 4x minus 3 into 2 minus 6 equal to 0. So 4x minus 6 equal to 0. See, when we find out the values, no, we should keep the coefficient of this. See, here I know, here I am getting a 4. So will it satisfy this? Like that we have to think. So 4x minus 12 equal to 0. Then 4x equal to, we have to take that negative 12 to the right side, so it will become positive 12. Then x is equal to 12 by 4, that is equal to 3. Thus we got another pair of values, x equal to 3 and y is equal to 2. Now, see, we have given x equal to 0, then x equal to 3, and if x equal to 6, we will get another solution. Means here we have a 3, no? We are giving a multiple of 3 here. So x equal to 6 will give us a value. Let us try that. X equal to 6. So 4 into 6 minus 3y minus 6 equal to 0. 4 into 6, 24 minus 3y minus 6 equal to 0. 24 minus 6, 18. 18 minus 3y equal to 0. Next, we have to take this positive 18 to the right side. So, minus 3y equal to minus 18 or y equals minus 18 by minus 3. That is 6. Thus, we got another integer value, no? So, x is equal to 6 and y is equal to 6. This is also a solution. So, we can plot that. Next, we have to take the second equation like this. This is our second equation. Here, if we give x is equal to 0, what happens? 3y, see x is equal to 0, no? 0 plus 3y minus 9 equal to 0. And next step, we will take this minus 9 to the right side. So 3y is equal to 9 or y equals 9 by 3. That is equal to 3. Now, next one, if we take x equal to 3. If x equal to 3, see here we have a 3 and here also we have a multiple of 3. That is why I chose 3 here. Okay, x equal to 3. So it will become 3 plus 3y minus 9 equal to 0. 3 minus 9. 3 minus 9 is minus 6. So 3y minus 6 equal to 0. That is 3y equal to 3. Minus 6 going to the right side. So it is positive 6. Now y equals 6 by 3. That is 2. Okay, we got two pairs. No, x equal to 0, then y equal to 3. X equal to 3, then y equal to 2. We move. One more value we need, no? So let us try x equal to 6 because we are having multiples of 3 over there. No, x equal to 6. What happens? 6 plus 3y minus 9 equal to 0. So 6 minus 9, that is minus 3. So here we have 3y minus 3 equal to 0. Then 3y is equal to minus 3 taken to the right side, positive 3. So y is equal to 3 by 3, that is 1. Thus we got another integer pair, that is x equal to 6 and y is equal to 1. So we can plot that. So these are the values which we have to plot. First, let us observe x, only positive values are there for x, no? And for y, we have negative 2. Okay, so let us start from here. This is our x-axis and y-axis. Let us take this as a y-axis. Okay, so this is x, x bar, y, y bar. This is our origin. Now, only up to 6. See, the maximum value for x and y is 6. No, so let us take like this. This is 1, 2, then 3, 4, 5, 6. Because not that much big values are there. No, that is why we chose like this. Then here also 1, 2, 3, 4, 5, 6, like that. Here this is -1. This is -2, like that. Here it is -1, and this is -2, like that. Okay. First we have to plot this one. Okay. Let me take blue color for this line. So 0, -2. 0, -2. -2 on y-axis. This is that point. No. Let me term it as A. A is actually 0, -2. Now 3, 2. On x we have 3, and on y we need 2. So this is the point. 3, 2. So let me take name it as B. So B is 3, 2. Next we need 6, 6. On x we need 6, and on y also we need 6. So this is the point. So this is 6, 6. Now let us join these 3 points. We got a line like this. Okay. Now let us write down the equation. 4x minus 3y minus 6 equal to 0. That is what we have from now. Now let us take the next one with green color. Okay. See, here we have 0, 3, 0, x 0, and y 3. This is the point, no? So let us take it as P. P is 0, 3, and 3, 2, x 3, and y 2. So it's same point. Q. Q is also 3, 2. See, from here itself we know this is the solution, right? 3, 2 is common for both. Then 6 and 1. On x it is 6, and on y we need 1. So this is the next point. I name it as R 6, 1. Now we have to join them with a line, single line. See, this is the required float. Okay, we'll write down the equation. Here it is x plus 3y minus 9 equal to 0. So we got the solution, this, right? 3, 2. X equal to 3, y equal to 2 is the solution. Graphically, we got it. And one more question was there, no, one more part was there for the question. Determine the coordinates of the vertices of the triangle formed by the lines represented by these equations and y-axis. Okay, see, we need the equation, the coordinates of the triangle formed by these lines and the y-axis. This is the y-axis, no? This is the y-axis. So we need this part. Okay, I'll show you. See, this is the required triangle. So we need the vertices of this triangle. Okay. So the vertices are, this is 0, 3, and this point is 3, 2, and this point is 0, -2. So these are the vertices of that triangle. This is the last question in this video. Solve the following pair of linear equations graphically. Also find the area of the triangle formed by the lines representing the given equations with y-axis. Okay. So first we have to plot these two lines. So first one is x plus 3y equal to 6. we need the corresponding x and y values which satisfy this given equation. Let us try. First, let us take x as 0. What happens when x is equal to 0? X equal to 0 means this is 0. 0 plus 3y equal to 6, or 3y equal to 6, y equal to 6 by 3, that is 2. Okay, enough. We got integer pair x equal to 0 and y equal to 2. Now, let us try x equals, see here we have 3 and here we have 6, both are multiples of 3. So let us take the multiple of 3, x equal to 3. Okay, so 3 plus 3y equal to 6. So 3y equal to 6 minus 3, right? That 3 going to the right side. 6 minus 3 is 3, so 3y equal to 3, or y equal to 3 by 3, that is what. Thus we got another pair, x equals 3 and y equal to 1. Now, let us check what happens when x equal to 6. See, we are trying with multiples of 3. See, here also we have 3, here 6, like that. So, x equal to 6, the equation will become 6 plus 3y equal to 6. So, 3y equal to 6 minus 6, that is 0. Right? On both sides, we have positive 6, we can cancel them. So, y equal to 0. Okay, so x equal to 6 and y equal to 0. Thus, we got 3 points to prove. Enough. This is our second equation. Okay, so let us try x equal to 0 first. What happens when x equal to 0? 2 into 0 minus 3y equal to 12. 0 minus 3y equal to 12, or minus 3y equal to 12. So y equal to 12 by negative 3, that is negative 4. Okay, so we got one pair of values, x equal to 0 and y equal to minus 4. Now, next let us check what happens when y equal to 0. What happens when y equal to 0? 2x minus 3 into 0 equal to 12. Or we can write, this is 0, 2x minus 0 is 2x itself. So 2x is equal to 12, or x is equal to 12 by 2, that is 6. Thus we got another pair, x equal to 6 and y equal to 0. Now, let us check what happens when y equal to 2. Okay, what happens when y equal to 2? How we are checking is, here we have a 2 and here we have a 12. See, both are multiples of 2. So I am giving a 2 here because all the terms will be multiples of 2, like that. Common sense or just a logic. Okay. So let us try with y equal to 2. So 2x minus 3 into 2 equal to 12. So 2x minus 6 equal to 12. So 2x is equal to 12 plus 6, right? Minus 6 going to the right side, so plus 6. So 2x is equal to 18, or x is equal to 9. 18 by 2, that is 9. Thus we got x is 9 when y equal to 2. So we got 3 pairs of values which we can plot on graph paper. We have to plot these two lines, right? So first we have to observe all the x values are positive here. Only negative 4 is there for y, right? So x-axis we need only positive values. Okay. So let us take this as our x-axis. Now, and y we need negative values as well, no? So let us take this as our y-axis. Okay. This is x. This is x bar. This is origin. This is y. And this is y bar. Okay. So here also not that much big values, no. So here let us take it as 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the maximum value for x, right? So it is possible to plot these values here and here -1, -2 like that. Here it is 1, 2, 3, 4, 5, 6, 7, 8 like that it goes. And negative side, on negative side, here we have -1 and here we have -2 and here we have -3 and here we have -4. So we have to extend our y-axis a little bit downward. Okay. Now, -1, -2, -3, -2. Okay. Which are points we have to consider? First one is 0, 2. Okay. 0, x0 and y2. This is the required point, no? Let us take it as A. So A is 0, 2. Next, B is 3, 1. X is 3, Y is 1. So this is the required point. B is 3, 1. Then 6, 0. This one, no? X 6 and Y 0 says 6, 0. Next, we have to join these 3 points we got now. And we have to write down the equation of the line represented by this. This is x plus 3y equal to 6. See, we have write down this one. Next, we have to plot this, right? So let me take it with blue color. 0, -4, first point. 0, -4. This is the required point P. So P is 0, -4. Then 6, 0. See this point, right? Okay, that is enough, no? 6, 0, Q. Again Q, okay. 6, 0. Then 9, 2. This is our 9 on x-axis and 2 on y-axis. See, this is 2 on y-axis. So this is the point R. This is 9, 2. Next, we have to join this P, Q, and R. Okay. Thus, we got that line. We have to write down the equation 2x minus 3y equal to 12 is this line. Now, one more part was there for the question. Also find the area of the triangle formed by the lines representing the given equations with y-axis. Okay, with y-axis. See, we have a triangle over there. This with y-axis means this is the required triangle. So triangle AQP is the required triangle. We have to find out the area. See, here we have 2. See, here we have 2 and here we have -4. What is the distance between these 2 points? That we can take as the base, right? And this as the height. We know the area of a triangle is half of base into height. Okay, so area of triangle AQP is equal to half of base into height. And here we have taken the base as AP and height as origin. Origin, let us take it as OQ. Now, what is AP? The distance between the point 2 and -4. So it is 2 minus -4, that is 2 plus 4, that is 6. 6 units is the base. Or we can count 1, 2, 3, 4, 5, 6. See, 6 units are there in between A and P. So it is 6. Next is OQ, this distance. This is 0 and this is 6. So in a 6 unit distance, no? Or we can count 1, 2, 3, 4, 5, 6. So this is also 6. That is the area is half of 6 into 6, that is 36. So half of 36, it is 18. 18 square units is the area of the required triangle. Hope all of you understood. Thank you.